You can follow along in Aware, or you can check your answers, or you can watch these videos later if you need to. So I'm just going to go in order and get through as much as I can by the end of this class period, and then I'll stop recording and I'll do it in chunks if needed, if we don't get through it all. All right, so in number 1, they give us the function and ask which of the following represent an inverse. So what we need to remember is that term inverse. Okay, so remember inverse functions, we switch x and y if we're solving algebraically. Okay, graphically, they are a reflection of each other, the function and its inverse reflect across the line y equals x. Okay, they reflect line y equals x. So graphically, you could do this in Desmos if you wanted to go and type each of these in and compare the graph. Okay, and then you don't have to do the algebraic work. Okay, so what that would look like Desmos. Okay, so I could type in my equation, 1/5 x minus 3. Okay, so there's the line that I'm starting with. Okay, and remember you can change the colors of those if you want to. Okay, and then here are inverse options. Okay, so first of all, remember when we write the inverse, we write it f and then the little -1 superscript and then x. So the inverse of f of x, or how these are written, D is written incorrectly. Okay, the format of the function notation. Okay, so but let's check the rest of these. So -1/5 x plus 15 is what this one says for A. Okay, and I can zoom out here, and these should reflect across the line y equals x. So it's probably a good idea for us to put that line y equals x in there. Okay, I'm going to make it a red dashed line. Okay, so if these were a reflection of each other, folded along this red dashed line, everything would match up from the original line to the new line. Those definitely do not, right? Everybody can see that? So that first answer choice is out, okay? So that is not it. So then the second answer choice is -5 x plus 15. So let's take a look at those. Okay, well that's closer, but still not quite it. Okay, that intersection of the two lines is not happening on the line y equals x. Okay, so let's check the next answer choice. Says 1/5 x plus 3. Okay, looking at the graph, that's not it. So let's check that last one, 5x plus 15. That's the one. Okay, so it is a typo the way that that -1 is written here instead of in between the f and x. So I'll get that fixed and Aware. Okay, but the 5x plus 15 is the one that when graphed, it is a reflection from this black line to this blue line. If I folded it over the line y equals x, those would match up. So that's how you could check graphically for inverses. Okay, so inverses graphically reflect across the line y equals x. Okay, so we got D there. Now, algebraically, in case you prefer to do this algebraically, okay, you are switching x and y. So first of all, you have to replace f of x with y. So this would be y equals 1/5 x minus 3, and then I would switch them. So I would say x equals 1/5 y minus 3, and then solve for y. Okay, so then I would take 3 and add it to the other side. 5x plus 3 equals 1/5 x, or sorry, 1/5 y. And then to get rid of the 1/5, I would multiply by 5. So I would multiply both sides by 5. The entire other side gets multiplied by 5. So that gives me 5x plus 15. And then you rewrite it in function notation. So this is the inverse. So f inverse of x is 5x plus 15. So algebraically, you can solve it by switching x and y and solving for y. And graphically, you can work backward from your answer choices. Okay, so whichever of those two methods that you prefer, okay, you could use either one of those. All right, in number 2, it says, given the function, and they give us this absolute value function, has been transformed from the parent function, the absolute value parent function. The graph of f of x is the effect of the graph of f of x being what? Okay, so in Aware, this looks a little nicer. These are drop-down choices for each of these blanks. When I make it a PDF like this, it just lists all the choices. So we're just going to select which answer choice. Okay, so what we need to remember is that your A value in front of the function, so it's outside the function being multiplied. I'll write this out actually. Let me get my pen back. So just, it doesn't matter if it's a quadratic or an absolute. Your A is outside, your minus h is inside, and your plus k is outside. Okay, the only thing that changes from absolute to quadratic is that instead of these absolute value bars, it would be parentheses and then squared. Okay, so but that A outside there, just trying to highlight, get out of here. Okay, well, that's not what I wanted to highlight. I don't know what's going on with this. Okay, well, whatever. The A outside is your vertical stretch or compression. If A is anything other than 1, you have to remember that it's going to be vertically stretched or compressed. If it is greater than 1, which 2 is greater than 1, then you have a vertical stretch. Okay, so we are going to circle vertical stretch. Okay, and that's because of that 2. Then, if your H and K, those are your shifts left and right. So remember, it's minus H in the equation. So it's the opposite sign that you see. So minus 4 means that it's going to the right 4 units. So 4 units to the right, because the H is a positive 4. The minus came from the equation. Okay, and then your K on the outside, okay, is your vertical shift. So this is a plus 1. So this is going, this is another typo. Let me fix that. That should be a 1. That might have been confusing. It's 1 unit up. Okay, so a couple typos I'll need to fix in Aware. Okay, but H is left or right, the opposite of the sign that you see. K is up or down, and A is your stretch or compression. If that A was less than 1, so if it was a fraction less than 1, that would have been your vertical compression. Okay, so you've got to remember those transformation rules. So let's apply those again here in number 3. It says this has been transformed from the absolute value parent function, and we're describing the effects again. So the one thing that I see here that I didn't see in number 2 is that A value is negative. When your A value is negative, that's when you reflect or flip your graph over the x-axis. So because of that negative, I know it's reflected. Now, because of the 2, I again know that it is vertically stretched. And then my H, there's if you want a hard copy, you can have that, but this is just the review and aware. Then your, did I switch to blue? I did. Your H. Now remember, it's the opposite sign of what you see. I see +5. So that means that my H is actually -5. And so I'm going to the left 5 units. And then my K is -7. So I am going down 7. Okay, so that's knowing transformation rules, knowing what A, H, and K do to your graph, how they affect your graph. All right, in number 4, it says that Xavier, Yang, and Zach are brothers. Xavier's the oldest, Zach is the youngest. The sum of the ages of the 3 brothers is 50. Xavier's 4 more than twice Zach's age. The difference between Yang and Zach is 6 years. Which system of equations could be used to determine the age of all 3 brothers? So they're not asking us to solve for their ages. They're just asking us how we would set up the system if we wanted to solve. So I'm going to go through each of these sentences up here and break them down into an equation. The sum of the ages of the 3 brothers is 50. Okay, sum means to add. So if I'm adding all 3 brothers together, luckily their names start with X, Y, and Z. How handy. So the sum of all 3 of their ages is 50. So that's definitely one of the equations. So these all have that one correct. Let's see if D did as well. Yeah. All right, so I can't eliminate any based on that first equation. They've all got that one right. Then the other pieces of information that they give us, they tell us that Xavier is 4 more than twice Zach's age. So twice Zach's age, so 2 times Zach's age. 4 more means to add 4, and that would give us Xavier's age. Xavier is 4 more than twice Zach's age. Okay, so let's see. 2z plus 4 equals x. This one's got the x and y, or x and z mixed up, so a is out. 2z plus 4 equals x. Z plus 4 equals x. Okay, so I can only eliminate answer choice A so far. So then the last piece of information is that the difference between Yang and Zach is 6 years. Okay, and they tell us right here, Zach is the youngest. So Zach would be the one I'm subtracting. When I find the difference, difference means to subtract. So that means Yang's age minus Zach's is 6. So why might Yang minus Zach? First of all, Xavier wasn't in that at all. We had already eliminated A though. But Yang minus Zach equals 6. That one looks good. This one has it backward, has Zhang minus, or Zach minus Yang, that has it backward. Okay, so that knowing that Zach was the youngest was pretty pivotal. And then this one has the sum, that's not right. Okay, so we narrowed it down. We found that it must be answer choice B. Those are the equations I would set up, and then I would solve the system, and I could know how old they all were. Now remember, to solve systems, so this one's looking for a solution. I showed y'all how to do this in Desmos. Yes, we can do this by hand, but that is a lot of algebra to do by hand, and you've got a lot of questions on this test, so I would definitely recommend that you use Desmos. So I'm going to show you, refresh your memory on how we do systems in Desmos. Now, if it was a 2-equation system, you're just graphing the 2 functions and looking for the point of intersection. So if it was 2 lines, you're just looking where do they cross. But when it's 3 variables, so we have x, y, and z, and there's 3 equations, it was a little bit different. Okay, so we're going to type all of those in just as they're given to us. And anything that has that extra variable of z is not going to show up on the graph until we add a slider. You can add the slider now, or you can type all of your equations first and then add it. it doesn't really matter. Okay, so then my third equation is 6x plus 7y plus 6z equals 4. Okay, so notice none of these show up on the graph. There's nothing on my graph because they all have z and we don't know what z is. So on any of these, it doesn't matter which one, but on one of them, you have to click add slider for z. Then they're all going to appear. So the z slider is what you're moving until you find where all three of those lines intersect at one point. Okay, so here I'm sliding it until I see all three of those intersect at one point. And it looks pretty close to where the graph popped up. So let's go look at our answer choices, because I'm seeing decimals where it popped up. So let's see. They're saying no solution is definitely out. These three lines definitely intersect. Okay, so there is a solution. Infinitely many solutions means that they're all the same line and they all intersect always. These are three different lines. So C and D are definitely out. So it's at one of these two options. So looking, and they're in X, Y, Z. Your answers, solutions are always in that alphabetical order. So let's check the Z when it's 6 and the Z when it's -2. Those are really our only two choices. So when Z is -2. Oh, that looks pretty good. And you can zoom in on that. That looks like they're all, well, actually, that's slightly off if I zoom in. They're not all three intersecting there when Z is -2. So let's check when Z is 6. Zoom back out over here and zoom in. Now that looks like they're all intersecting at the exact same point. So it is happening when I set the slider for Z to 6, the X is -3 and the Y is -2. So it's -3, -2, 6. So that is answer choice A here.
This is not the copy for that.
Okay, then I didn't print those.
Oh, okay.
They're in Aware. Okay. So let's take a look at the next one. Okay, so this is another one, and it's only asking for Z in the solution set. So we're gonna do the exact same thing in Desmos. We're gonna type our three equations, but we only want to know Z. We don't need X and Y as well. So -4X minus 8Y plus 9Z equals -3. And -2X plus Y minus 5Z equals -4. 3X minus Y plus 5Z equals -2. So we're going to add that slider for Z, and then I'm going to look for where all three of these intersect at the same point. I'm going to go back home. Okay, so I'm going to move this slider. Okay, I'm going to have to move this graph a little to see this a little better. All right, there it is. You'll see all three are intersecting at one point. They're not asking for X and Y here. They're asking for Z. What is the Z value that we just slid the slider to get this all intersecting at one point? -3, right? And that's all they're asking for here. I will go back and check that. Let's see if there's more than one. Let me zoom out. Yeah, they're not all three intersecting there. So I'll have to check that. Let me double check that I've got these typed correctly. Just see if I had a typo on any of those. Negative 4x minus 8y plus 9z equals negative 3. Negative 2x plus y minus 5z equals negative 4. 3x. Oh, look at that. I do. See, this is supposed to be a minus. Be careful that you type them in correctly. So minus y plus 5z equals negative 2. And yeah, there's where they intersect, is when z is 5. Good catch. Thank you. So yeah, double check that you don't have typos when you're typing those in from Aware. Okay, be very careful. I had my minus changed to a plus and it gave me the wrong answer. Okay, so just be careful with that. So I take that back. The z should be at 5. I'll fix that here. Oops, thought I had an eraser. Okay. All right, another system. So let's double check that I type it correctly this time. All right, so 2x minus 2y minus 3z equals 0. 8x plus 4y plus z equals 2. And 8x. What is that? Oh, okay. Thank you. Yeah. All right. Sorry, where was I? 8x minus 3y minus 9z equals negative 4. All right. 2x minus 2y minus z, 0. 8x plus 4y plus z equals 2. 8x minus 3y minus 4z equals. Okay, so now I'm going to add my z slider. I'm looking for the point where all three of these intersect. So you can zoom in to make that easier for you to see. And just slide that z. There it is. All three are intersecting at this one point. And now it was asking for which variable? It's asking for y this time. Okay, so the z is at 2. And then the x is at 1, the y is at negative 2. So your answer here should be negative 2. The y value of that system solution. All right. 8. It says place the option that correctly completes the sentence. So this is a drag and drop in Aware. So these are essentially your answer choices. It says for a science project, Joseph launches a model rocket. This is what we did really recently, just on the last test we took. Here's the function, and it represents the height in feet that the rocket goes after s seconds. So height equals all of this, and s is the number of seconds. Okay, it says the maximum height that the rocket will reach is blank. So we are just going to graph this equation. Get rid of all this. And find the maximum. Now I'm going to use y and x instead of h and f. Negative 3x squared plus 6x plus 45. Okay, so let's look for the maximum. Is the maximum the x or the y? The y. It says that the equation, the y value, is representing the height. So the height is the y. So 48 is our answer there, not the 1. The 1 is how many seconds it took. It would be 1 second to get to 48 feet high. Okay. Projectiles thrown in the air. This equation represents the path of the projectile, where x represents the amount of time in seconds. How long is the projectile in the air? Okay, so similar scenario, projectile in the air, except this time they're not asking us for the maximum. They're asking us for the number of seconds that it's in the air. So this one is y equals negative 3x squared minus 12x plus 96. Make sure I don't have any typos. All right, now how long is it in the air? Well, it's in the air until it gets here, right? If that h is representing the height, okay, the height is 0. That's when it hits the ground. They're asking us for the x-intercept. So you have to understand that in these scenarios, the x-axis is the ground, okay? So the height is 0, it's no longer in the air, and it took how many seconds? It took 4 seconds. Okay, so that one is 4. Okay, what are the solutions to this quadratic function? Okay, now when we were talking about solutions for systems, it was where they all intersected, but now we just have a single function. It's not a system. We've just got a quadratic. The solution is the x-intercept. Okay, now you could do this algebraically by factoring or using quadratic formula or completing the square. We learned lots of different methods, but graphically, it's just going to show you your solutions down here. So I got 6x squared minus 10 equals 11x. Now, when you type it in like this, where it's not set equal to y, okay, we've got terms on both sides of the equation, it's not going to show you the parabola, but it does draw a line through the solutions. Those are the solutions. Okay, if you want to see it as an actual parabola, you need to get everything to one side. If I moved that 11x over, it would be minus 11x, right? I could get rid of it over there. And I get the same two solutions, but I actually see it as a parabola. Okay, so that's at 2.5 and negative 0.6 repeating. Okay, now looking at your answer choices, they have them as fractions. If you're ever not sure how to convert a decimal to a fraction, you can always type the decimal in here and then just click that and it will change it to a fraction. So 5/2 is one of our solutions. That was positive 5/2. There's only one answer choice here that has positive 5/2. Okay, but you could still double check the other one was negative 0.6 repeating, which is negative 2/3. So it's positive 5/2 and negative 2/3. So that was answer choice C here. All right, all of the possible solutions, okay, when we did this, absolute values, solving absolute values, we said we isolate the absolute value expression, which it already is. There's nothing outside the absolute value bars on the left side of this equation, so it's isolated. And we would take what's inside and set it equal to the positive version of what's on the left, the other side, and the negative version what's on the other side. So we could do this algebraically. But again, if we have a single equation, doesn't matter if it's a quadratic, a linear, an absolute value, the solutions are the x-intercepts. So technically, I could just plug this in Desmos and look for the x-intercepts like I just did on that quadratic. So that's what I'm going to do because that's the easiest thing to do. Now, another way you could solve this, because it's multiple choice, I don't know why that went into 4. I did not mean to do that. Okay. Because it's multiple choice, you could also check your answer choices. So you could plug these numbers in for X and see which ones make this a true statement. Okay, so there's 3 different ways that I just said you could solve this. Okay, work backward from your answer choices, plug and chug, see what works. Has to make it true to be a solution. Okay, I think graphically is the easiest way. So I'm going to do, I need to get my absolute value bars down here. Oops, they were right there. Bless you. Inside that is 3x minus 3. And that is equal to 2x plus 8. Again, because I've got terms on both the left and the right side, it's not going to actually show me the absolute value function, but it sure will tell me the solutions here where it crosses the x-axis. I don't know why it's not letting me click on them, but you can see on your answer choices that looks to be at about -1 and +11. If you want to actually see the absolute value, that V shape, you need everything to one side. So I could subtract the 2x and 8 and write that as -2x minus 8 all on one side. Now I actually see that shape and see it's still -1 and 11. So it doesn't matter if you see it as the V shape or if it just shows you the solutions. They're the same, -1 and 11. All right, number 12. Again, which of the following shows the solution set? Okay, so which of these is a list of solutions to this? We can just use Desmos. Okay, so almost this entire test can just be done in Desmos. So this time it's a fraction. The absolute value is on top with 4x minus 2. That's over 3 equals 6. So I can see those solutions. It's at 5 and -4. So -4 and +5. If I want to actually see this as a V shape, the absolute value graph, move that 6 over to the other side. It would become a -6 over there. Now I can actually see the V shape, and those are still the same solutions though, -4 and 5. So you need everything to one side of the equal sign if you want to see the actual graph. But if you don't move everything to the same side, it'll still draw those vertical lines through your solutions. Okay, so either way. All right, in this one, it's asking you to graph. This is the parent function of the absolute value function. So you should definitely click over here, absolute value. And then when you graph it, I don't know how it pops up. I think it's kind of random, but we know that you should know that the absolute value has a vertex at the origin. Okay, and it's got like a slope of 1 to the right and a slope of -1 to the left. So when you're graphing in Aware, you just, I think, click on which function it is. You shift around to put the vertex where it should be, and then you have to plot a second point so that your graph is angled at the correct slope. Okay, but that's what it should be. And if you don't have that memorized, if you don't know that, guess what? You could simply come here and type in the absolute value of x and see where it should be and pick, and just click and you can see points. Okay, my vertex is obviously at 0, 0, and then I can plot a point at any of these. I don't know why it's so hard to get it on exactly 1, but at 1, 1, at 2, 2, etc. Okay, so I'm going to stop this video here with number 13. So this one got through number 13. I'll make another video in my next class, getting through more of the review.